Hello, teacher Jerry here. So the next topic we're looking at is redox. All right. So similarly, the big thing about this is that redox is a way for us to classify a reaction. So basically, redox simply means oxidize and reduce. Right. The word redox means oxidize and reduce. Yeah, so it's based on definition. All right. In short, we can call this SHOE, SHOE. Okay, and you will realize that actually oxidation state is the one that we'll focus on later. There will be another video that concentrate on how we calculate oxidation state and how we apply the oxidation state to redox questions. And oxidation state is related to electrons. There is a change in oxidation states because of the gain loss of electrons. So oxidation state concept is something similar to charge, but not really equal to charge. Now, for hydrogen oxygen, it can be quite straightforward. For example, if I give you a simple equation, okay, Mg plus CuO, copper 2 oxide, and you get copper, and you have MgO. So we will say that, Mg is oxidized because it gained oxygen to become MgO. Then CuO lose oxygen to becomes Cu, that's why it's reduced, right? It's based on this understanding, right? Decrease means lose oxygen, arrow down, then this one means gain oxygen. All right. And similarly, we can also do one for hydrogen. Okay, let's say we have this. So you can see F2 gain hydrogen, right? Gain hydrogen means reduce. So we can say F2 is reduced, right? Then HCl lose hydrogen becomes Cl2. That's why it's oxidized. All right. So that's how we use the gain loss oxygen hydrogen, right? But of course, not every equations involve oxygen hydrogen. That's why the most useful one will be the oxidation states. Okay, which later there will be another part where we focus more on the oxidation states. Right? And you can take a big look picture, right? Do I need to memorize both oxidize and reduce? No need. You can see that once you get one arrow, the rest are just opposite. And of course, oxidize is also opposite of reduction. Okay, so when there's no change in oxidation state, then they are non-redox reaction. Okay, so they are redox reaction, they're also non-redox reaction. And we also need to look at one more thing is oxidizing agent and reducing agent. Correct. So there are take note, oxidized and oxidizing agent are not the same, so they are not equal to oxidized. So sometimes the question can ask us, which substance go through oxidation or being oxidized? It's not the same as oxidizing agent. Okay, they are related, but they are not the same. So similarly, reducing agent is not equal to being reduced. Okay, we need to understand that these are four different concepts. Oxidize, reduce, oxidizing agent, reducing agent. They are related, but they are not the same. All right. So we need to understand is that oxidizing agent is that they are the cause, they cause others to be oxidized. So that means if I give you money, then in the process I will be poorer. They are reduced in the process. All right. Similarly, likewise, reducing agent when it cause others to reduce, they will be oxidized in the process. So if you look back at these two example, right? Mg is oxidized, becomes MgO. So we can say that Mg is also the reducing agent. Right. Similarly, CuO is reduced, then it is also the oxidizing agent. Right. Because that's why I say CuO reduced. Reduced by who? Reduced by Mg. Right. Because there's only two reactants in the system. Right. Just like similarly, if A and B is in the room, if B is being killed, then A will be a prime suspect, and vice versa. Right. So that is our main understanding of oxidizing agent, reducing agent. Of so many oxidizing reducing agent, there are two common one that we use. Okay. These are all common reagent because they will show color change. Okay, potassium iodide, the reducing agent, oxidizing agent, the potassium manganate 7. Right, also sometimes use this formula KMnO4. Right, Ki. Okay, so what we are saying is that when you use an oxidizing agent, it means when you put KMnO4 into unknown, right? This is an oxidizing agent, and we know oxidizing agent will be reduced. So if it change color, right? From purple to colorless, right? So actually, potassium manganate, right, is a very dark purple color. So when it change color means there's a reaction. It means it has been reduced. Therefore, X is the reducing agent, right? That's why we use the oxidizing agent test for reducing agent. And likewise, we can do a similar concept thinking for the reducing agent. Very straightforward. Just know what is oxidize and reduction, and knowing that the difference between oxidizing agent and oxidize, reducing agent, and reduce, they're not really the same. But how we apply will be quite similar to it. Okay, you catch the next video for the how we use oxidation state, how we calculate, and how we use it as an example to answer a redox question. Can I see you in the next video? Thank you.